My name is Shai Tsur here at Seagate. I'm in charge of working with our different partners and customers to build an ecosystem around the Kinetic product that we'll be talking about today. So I'm here to kind of give the quick overview of what we're doing with Kinetic. And after meet Jim, will give a more technical presentation. So we, the Advanced Storage Group, Kinetic, why are we here, and what's the purpose of what we're doing? We're looking ahead at the world of storage in a couple of years' time, and we see a couple of things going on. So, if we're looking back at 2010, there was about 100 exabytes of total storage per year. Looking forward to 2020, that number kind of mushrooms to 7.3 zettabytes, of which the vast majority of which is both unstructured and in the cloud. Right? So we have this challenge of 5 years down the road, how are you going to stand up 6.5 zettabytes worth of cloud unstructured storage, which is both a physical challenge. So if I took the drives and kind of stacked them neatly next to each other with about an inch worth of space, that would circle the globe if we were going for 4 terabyte drives. But beyond the kind of physical capacity problem, there's also an economic problem. That by our calculations, using today's architecture, today's technology, it would cost something on the order of $240 billion to stand up that amount of storage per year. So clearly there's a huge demand and there's a huge challenge of how we get to these numbers and how we can get to this capacity moving forward. So this is what Kinetic is here to kind of address. And we're doing it in a way that's kind of sort of different to where Seagate's been in the past. In fact, the whole Advanced Storage Group, our purpose beyond Kinetic and everything we're doing is to look at drive innovation, not just at the drive level, but to look forward, like how are these drives living, what's the ecosystem around these drives, how do they slot in there? And we're doing it with an approach that's a lot more open and a lot more kind of partner-based than we have in the past, with the real emphasis on open source and open standards, working closely with OpenStack, with Open Compute Project, and others, and working with software-defined storage partners, both open source and proprietary, which we'll be talking about later today. So, what are we aiming to do? So, if we're looking at storage as it is today, and the underlying foundations of the drive haven't changed. The basic technology hasn't changed over the past couple of decades. At the end of the day, it's kind of a spinning head, blocks and sectors, and all the big technological jumps that have happened since the 70s, basically, have been in response to what the applications need to do with that storage. So today, if you have storage management software and it wants to write something to a drive, it has to go through all sorts of layers of stuff. It has to translate it to POSIX. It has to kind of go down through the fiber channel to the storage server, which is responsible for things like rating, eventually down through the SAS cables to the device itself, and gets written on a certain log or certain sector. And then when you want to read that information, you have to kind of go through this whole convoluted system as well. This worked well in a world where you absolutely needed to know what block and what sector the information was written on. But if you're looking at object storage and applications like that, this isn't actually as necessary. And in fact, we thought, in a world that's object-based in the cloud, we wouldn't really want to go like this. We had to start designing the whole system end to end. If we had a clean sheet of paper, it wouldn't look like this. We want to transition from a world that looks like that to a platform that looks more like this. So the application can access the drives directly over Ethernet. And that's the idea behind Kinetic. In order to get there, we needed a couple of things. So the idea behind the drives, we started with a standard magnetic drive. The case of the first product that we're shipping is based on our 4 terabyte 5900 RPM enterprise drive, to which we added two elements. One is an additional chip, which turns these drives into native key value stores. The second is Ethernet connectivity, and you need really both of these elements in order, we believe, in order to kind of get to where we're going. So this is the drive. It looks like any standard 3.5 inch drive. The difference is that we took the connectors, the SAS connectors that are on that drive, and repinned them to speak Ethernet instead of SAS. So in a sense, you take the drive and you end up with two 1 gig Ethernet connections to IP addresses per drive. And you have a situation where you now have applications talking directly to drives. You have multiple applications talking to the same drive. The drives are individual actors inside the system. They can talk to each other. So you're getting really kind of the whole disaggregation of the compute level, the compute from the storage. Okay. So the New World Order kind of looks like this. At the bottom, we said we have the drives. The drives do what they know how to do best. In this case, it's the space management. Its security features, its authorization. Between the drives and the application stack, you have both the key value API and libraries that will work with the application partners again. This is Swift Stack, Scality, Ceph, Bash or React, or, whichever storage system you want to use. And those commands are translated through Google Protocol buffer-based transport layer to the drives themselves. So the application stack focuses on what it knows how to do as far as clustering, replication, and all the other management part of the software there. What's missing from this whole setup, as you'll notice, is the storage server element of the data center. I think this is where the big jump comes in terms of affordability and in terms of kind of the economically poor that you need to get to that goal of the storage. So as far as what we believe the values are, there's a couple of major values. The first is on TCO at the system level, at the data center level. By getting rid of that storage server tier, you're getting savings in a number of different areas. One, of course, is the actual cost of the storage servers themselves. But there's also a TCO gain to be made from OpEx, both on the staffing side and the power side. So on the staffing side, because you're getting rid of these large single points of failure, if you have a storage server with 40 drives hanging off the back of it, and that storage server goes out, that's an emergency event. In a kinetic architected system, the drives are individual actors. If one of those drives goes out, that's routine maintenance, which means that the same staff that you have today can administer a much larger amount of storage than they are doing today. On the power consumption side, the slight power gain that you get per drive is more than makes up for the storage server again. It's being taken out of your data center. So you're getting, in some situations, up to kind of 50% TCO, kind of lower TCO by moving to a kinetic architected system. In terms of performance, we're getting gains both in terms of raw throughput and I/O utilization. This comes from the fact that in the kinetic system, data is streamed in an unstructured manner to the devices. Once those devices get those keys and values, the drives themselves do the space management, take the keys, order them, so you get streaming reads as well as streaming writes. And we're seeing kind of a performance gain that's between 3 and 4 times better than what we're seeing with traditional SAS drives. In terms of I/O utilization, by cutting out all that metadata overhead that we saw, by going through all those layers of extraneous technology, we're kind of getting a much better I/O utilization, much more efficiently. And in addition, in the kinetic system, you're essentially abstracting the storage layer from the application layer, from the management layer, which means that in terms of adding new technologies, for instance, the transition we had to 4K sectors was very painful from the standpoint of the application developers. Because that's now abstracted, it makes the transition, say, to something like SMR, which would otherwise be equally painful for the application developers, much more easy to do. Essentially, you're future-proofing your architecture to some degree. It also allows us at Seagate to introduce advanced management and data security features much more easily. So from the system standpoint, you've seen some of the devices boxes here. Whereas before you have a JBOD with drives talking up to 2 SAS expanders, talking to the storage server, talking to the rack switch. We're moving to this kind of configuration. We have, again, drives at 1 gig Ethernet each. They talk to 2 Ethernet switches in the box, and those go out with 10 gig connections up directly to the top of the rack. Essentially, there's no new ports. You're really just making the transition from the SAS switch to Ethernet. From the standpoint of the network, again, not much has changed here. So, whereas before, kind of go from the client through the top of rack switch to the core, the top of rack switch to the data nodes in the SAS shelf. Again, here you're doing almost the same thing without that last hop along the way. So there's no real impact to the data center networking. Okay. We have a number of hardware partners that we've been working with, several of whom we'll be talking today, doing different boxes and different configurations, both kind of big form factors and smaller form factors. It is that we believe that this is the way to get the densest possible storage out of your data center. And we're building out a developer ecosystem. As I mentioned before, our whole purpose doing Kinetic is going to work with an open source environment. The key value API is open source. The transport is open source, and we have libraries for Python, Java, C, C++ that we're making available at our developer site for anyone to kind of go ahead and leverage the capability of this technology. So, kind of to summarize, we believe that this is the way to kind of a great leap forward and scale out object storage because you get the TCO gains, because you get the disaggregation of storage from compute, and the flexibility that comes around that, and because of the performance gains and the future-proofing available.